Right, we now turn our attention to defining our second logical operator or gate, the AND gate. This time I have a special pair of goggles that has the filter AND on it. I have now got two light bulbs, light bulb A and light bulb B. Going through an AND gate, you can see the shape of the AND gate has a straight back, completely straight back, and a very rounded nose. Because we have two inputs now, the statement that bulb A is on and the statement bulb B is on, we therefore now have 2 times 2 or 4 possible permutations that we need to cater for. And there's a very easy way to draw up a pattern that will cater for all possible permutations. I go to the my last possible input. In this case, it's going to be bulb B, and I recognize that I'm going to have one of two possible states for the statement, that either the bulb A is on is going to be false or it's going to be true. But because I now have to do this for 4 possible permutations in total, I now need to repeat this pattern. Moving on to my input just to the left of that, which is light bulb A is on, either false or true, I now simply take the same pattern and double it up. So instead of writing 1 0, I write 2 zeros, and instead of writing 1 1, I now write 2 1s. So this gives me all possible inputs for my AND gate. Right, off we go. Looking at the statement from the point of view of looking at it through my AND goggles, is the statement A and B are on. The statement A and B are on, looking at it, it's either true or false. Well, looking at this, I can see that it's not true. So we put a 0 in the column for that possible permutation. Alright, moving on to our second possible permutation. Bulb A is on is still false. Bulb B is on is now true, because bulb B is in fact on. Right, looking at it through the perspective of the AND goggles, A and B are on. False. A and B are not both on. Permutation number 3. Bulb A is on, is true. Bulb B is on, is false. Let's have a look at it through the AND goggles. A and B are on, false. Finally, bulb A is on, is true. Bulb B is on, is true. Let's have a look at it from the perspective of looking at it through my AND goggles. A and B are on. Yes, that's now true. It's a true statement. So, we can summarize what has happened here. The only time we actually got a true statement out of the AND operation was when both bulb A and bulb B was in fact on. Both the statements had to be true. If either one of the statements was false, or even if both were false, we got a false out. So this leads us to the following short circuit definition. When dealing with an AND, if I hunt down every place where the statement is false, I can automatically say, as long as if any one of the inputs ends up being false, then automatically that output has to be false. Because the only time I do get true out, or 1 out, is when the inputs are all 1s. So the short circuit definition for an AND is the minute I hit a 0, I can automatically say that the output is going to be a 0. What I'm left with then needs to be checked carefully. Are all the inputs 1? If the answer is yes, then I put a 1 in that column. That, ladies and gentlemen, is the definition of the AND.